and remove the brain. Here are the two vertebral arteries passing through the dura. The vertebral arteries join together, forming this large artery, the basilar artery, which runs upwards and forwards, above and behind the basilar part of the occipital bone. Now that we've followed the internal carotid and vertebral arteries into the cranial cavity, we'll see how they supply the brain. We'll also see the set of arterial connections known as the arterial circle or circle of Willis. So far, we've seen the internal carotids entering up here, the vertebral arteries entering down here and joining to form the basilar artery. Now, we'll complete the picture. To name the vessels we're looking at, we'll start with the main branches of the internal carotid. The internal carotid gives off the anterior cerebral and posterior communicating arteries, then continues with a different name. From here, the vessel is called the middle cerebral artery. The two anterior cerebral arteries curve towards each other above the chiasm, then pass upwards and forwards, close together, to enter the longitudinal cerebral fissure between the two cerebral hemispheres. Just above the optic chiasm, the two anterior cerebral arteries are connected to each other by this very short anterior communicating artery, which is part of the arterial circle. The middle cerebral artery, which is the direct continuation of the internal carotid, curves laterally. It enters the lateral cerebral fissure between the frontal and temporal lobes. We'll follow it there shortly. The pale areas on this artery are patches of atheroma. Now we'll go round to a view from behind to see the vertebral and basilar arteries and the vessels that arise from them. Here are the two vertebral arteries joining together to form the basilar artery. Down here, four inferior cerebellar arteries usually arise, two posterior and two anterior. These are the posterior ones. In this specimen, the anterior ones are represented by this one vessel. In addition, the basilar artery gives off small branches to the pons and this labyrinthine artery that supplies the inner ear. Four branches arise from the top of the basilar artery, these two superior cerebellar arteries, and the two terminal branches of the basilar, the posterior cerebral arteries. The posterior cerebral artery curves backwards and laterally above this nerve, the oculomotor. It curls around the cerebral peduncle. We'll look at its course in a few minutes. Just as it turns, the posterior cerebral artery is joined by this small artery that we've seen already, the posterior communicating artery. The posterior communicating artery completes the arterial circle. The arterial circle provides connections between the right and left sides and also connects the vertebral and internal carotid systems. It's more of a hexagon than a circle. Its component parts, from front to back, are the anterior communicating artery, the anterior cerebral arteries, the internal carotids, the posterior communicating arteries, and the posterior cerebral arteries. The arrangement is often somewhat asymmetrical. Here, the left posterior communicating artery is very small. The vessels we're looking at lie in the confined space between the floor of the cranial cavity and the underside of the brain. To see how they're related to the brain, we'll look at a brain that's been removed from the body together with its arteries. The arteries have been filled with red latex. Over this area, the arachnoid layer and the many small vessels in it have been removed so that we can see the major arteries. Here's the optic chiasm. Here beneath it are the divided ends of the internal carotid arteries. Here's the anterior cerebral artery passing around the optic chiasm, which will pull downwards. Here's the anterior communicating artery. The two anterior cerebral arteries turn upwards to enter the longitudinal cerebral fissure. We'll follow them shortly. The internal carotid, which we'll go back to, gives off the posterior communicating artery, then continues to become the middle cerebral artery. The middle cerebral artery enters the lateral cerebral fissure between the frontal and temporal lobes of the cerebral hemisphere. Coming from below, here are the two vertebral arteries joining to form the basilar artery, which is quite off-center in this specimen. Here are three of the possible four inferior cerebellar arteries. Here are the two superior cerebellar arteries. Here's the division of the basilar into the two posterior cerebral arteries. To follow the course of the anterior, middle, and posterior cerebral arteries, we'll divide the brain in the midline and look at just one cerebral hemisphere. Each anterior cerebral artery runs upwards and then backwards, close to the corpus callosum. It gives off branches which supply this area on the medial aspect of the cerebral hemisphere, and which then reach over the superior margin of the hemisphere to supply this area on the lateral aspect. Next, we'll follow the middle cerebral artery. Here it is again, running in the depths of the lateral cerebral fissure. The middle cerebral artery gives off branches which emerge along the length of the lateral cerebral fissure to supply this area on the lateral aspect of the cerebral hemisphere. Lastly, we'll follow the posterior cerebral artery. It runs laterally, just above this nerve, the oculomotor, then runs backward, passing around the cerebral peduncle. To follow it, we'll again look at the cerebral hemisphere by itself. Here's the posterior cerebral artery. It winds around between the cerebral peduncle, which has been divided here, and the most medial part of the temporal lobe. The posterior cerebral artery gives off branches which supply this area on the medial aspect and underside of the hemisphere, and this aspect on the lateral aspect. Now that we've seen the principal arteries of the brain, we'll move on to look at its veins, and at the channels that its veins drain into, the venous sinuses. The brain is richly covered with veins. Over the surface of the cerebral hemispheres, the veins emerge from the sulci, join with one another, and run upwards within the arachnoid layer. Here, behind the midbrain, veins converge from many directions to form this great cerebral vein. We'll see where that goes shortly.